and welcome to this talk. Yeah, the mic is running. From Fire to Blackfire, building a long-term observability strategy. It's a talk on how to regain control of the performance of your applications and how to stop firefighting. By the end of it, we should have a set of tools at our disposal to keep control of the performance of our application at all time. The idea is to create the condition for us to never have to firefight again. And let's see, in half an hour, we could be in this situation. But first, let me introduce myself. I am Thomas di Luccio. I am on the developer relations team at Platform.sh, and I work mostly, but not only, for Blackfire. I've been working with Blackfire for years. I have the great chance of doing many things I love in my position, like meeting you, lovely people, trying to build stuff with you, tell those stories, write codes, documentation, blog posts, and I love all of it. But there is one thing I truly hate, and it's working under pressure. I suck at it, I hate it. It's the beginning of the day. Let's raise your hands if you're like me and you try to avoid working in stressful situations. Yeah, OK, most of you. And now raise your hands, those who think they can perform well under stressful situations. You can be in both situations, actually. All right? Good. Ish. OK. Good for you. And now I have a question for you, lucky people. What do you do when your production is down? Scream is the first thing, yeah. But we have to firefight. What do we do in this situation? Well, we have to firefight. Oh, there is a line. We don't have any other choice. This talk is about stop firefighting, but if we have to do it, well, at least let's do it with the proper tool. And the first tool I'd like to introduce you today is the profiler, is Blackfire Profiler. So, quick note for those watching this from the future. So if you're watching the replay of that video, well, first, thank you. And you can try it for yourself. So go to books.b7e.io. B7e is short for Blackfire, and you can give it a try. This site is freely profilable by anybody without a subscription. It's great. And here, us now in Brussels, let's do this right away. So we go there. And the easiest way is some kind of simple blog based on Symfony. The easiest way of triggering a profile is with the browser extension, Firefox and Chrome. There is a big red button, and let's click on it. Of course, you can use the CLR, you can use the monitoring, you can profile anything you want. There's a lot of options. Let's wait a bit. Oh, the network is not too slow. Yeah, it's good. So we made our first profile. Let's click on the timeline view. Let me hide this. It may be a bit small, but I will zoom at the end. Well, it's a timeline. So you see the execution of your script command from the beginning there on the left to the end on the right. And one box is one function call. And top to bottom, you have the caller-callee relationship. So that function is calling that one, that one, that one. So that can go quite deep, depending on the complexity of your application. And the blue wave in the background is the memory envelope. So you see the evolution of memory over time. So you can see visually if you have some kind of memory leak with a sharp increase of the blue wave. That's super convenient. Let me display this. On that side, zoom, you have all the related metrics to your function. So you have a lot of metrics. There is over like 600 metrics available, and only the ones relevant to your runtime framework configuration will be displayed. And as for all metrics, you can see the cardinality and their contribution to multiple dimensions, I/O network, CPU, memory, world time, anything. And we will use this to understand a bit more how our application is behaving. And you will see later, spoiler alert, we will write tests, and we will rely on this. Another view that could help us understand how our application is behaving is this view, what we call the call graph. On this panel there, you have all the functions of your script. That's quite a lot. Of course, you can search it. And by default, it's sorted by exclusive time, meaning the time that function is actually spending doing stuff versus waiting for children to respond. So you can start by searching for blocking function that could be spending too much time or consuming way too many resources. Now let's see this weird tree. So that's a call graph. And again, one box is usually one function call, and on some occasion, like there, you have less impactful functions that are stuck together. It makes the graph a bit easier to understand. You can see that some of those boxes, function call or sequence of calls, have a colored border. They are making altogether what you call the critical path. So it's a sequence or sequences of calls consuming way more resources than all the other sequences of call. So even if you don't know a thing about that application or that framework, anything, and that could be the case when you're firefighting, like everybody is joining and try to debug something they barely know, you know, without knowing anything, that you know that what you're looking for is somewhere in that tree, in that specific sequence of call. You can remove the rest. You can also see that some of those boxes have a colored background. It means that those nodes are consuming way more resources than all the other nodes. So knowing those facts, and it's OK if you don't see colors, like colors are not that important. What matters is the intensity of that color. The stronger, the most resource intensive. That's the logic behind. So knowing this, we can zoom and try to understand what could be happening in this page we profile. So we are here on some doctrine stuff. We are creating a lot of entities, which is a surprise. We are creating, for this simple application, over 1,000 doctrine entities. We are, of course, iterating them all. It's a lot. We are climbing up. We don't know what's happening, but we have this load one-to-many collection. So we have this n+1 situation that's always banging us. And we keep on climbing, and we maybe found the culprit. So we can see that we are displaying one time a view. Makes sense. That view is making 25 calls to this twig length filter. And at the end, it ends up is loading a lot of entities, relationship, iterating them all. And what are we trying to do? Let's go back there. So it's a kind of simple block. We are loading 25 posts on this page, and we are displaying the number of commands. So we should go to the code base and assess this. We won't have time. But what I think is happening, that we are fetching all the entities only to count them at the end, which is not the best, most efficient way of working. So even in a few minutes, with an application we barely know, and a tool we start discovering, we manage to find a bug there. That's a very powerful tool. And you have more, well, first, no, you have more call graph at your disposal. There is one for the wall time, if you want the response time, the overall response time. And you have also some others for the contribution to I/O, CPU, memory, network. Each time you have a different tree, different call graph, and you will use one or the other depending on what you want to debug, and they will provide you with actionable insight on where to look for, what function or service call to investigate to debug your application. And don't worry, again, if you don't see colors, colors are different, but the logic remains the same with the colored background and border. It's all what matters. We also have a list of recommendations. That's great. So let me zoom a bit. Not convenient. You have a list of actionable insights based on the data we are collecting. And an advice, there is a how to fix CTA. So let's click this. This zoom is not super great, but it doesn't matter. We have some explanation about why we are selling you this and how can you fix this. Maybe it's configuration, maybe it's a coding pattern. You will have some insights. And my advice will be to get rid of as many recommendations as you can, as quickly as possible. It's doing stuff on its own, OK. More often than not, when you fix one recommendation in one place, it will have positive side effects on all different places of your application. So start by it. It's like having a friend pointing you in the right direction. You have an assertion tab. We will talk about this later. So if you make performance test, and we will do it in this half an hour, all the assertion will be evaluated and displayed there. You also have some information on your caches, so make sure that your caches are correctly configured and sized. Maybe start by it. Usually super interesting. You have a list of HTTP requests being made and SQL queries. That's awesome because, as a spoiler alert, I'm pretty sure that almost most of you, or all of you, are making too many SQL queries because we are all fighting this. And you will have some insight on how many SQL queries have been made. And one cool thing I want to show you before leaving that tool, we go back to the call graph. And we will search it here, and there is no demo effect. And we can identify the function called responsible for triggering that SQL query. That's super great when you have a large application and you don't know what part is doing what. So you can click on this magnifying glass here, and you have this new call graph being displayed. It's a subset of the call graph for that everything leading to that specific function. And again, we can climb up and see that we find this twig length filter in the view, meaning the view is responsible for triggering that SQL query on its own. So if you want to fix it, we should make another SQL query and inject it in the controller. And we found everything only with that tool. So let me go back there. So it's great. The profiler is a great tool and a great asset when you want to firefight, but not only when you have to firefight. When you are coding, it will provide you a lot of insight. It's awesome. But in a firefighting situation, it may not be enough. Firefighting for us is a bit like being a physician, a doctor at the emergency room of an hospital. You have a flow of patients and people coming with symptoms, and depending on the case, the same symptoms can mean one thing or the other. So we need a process and we need a tool to help us make a diagnostic. And this is what we need, and this is what we have. So the second tool I would like to introduce you is the monitoring. It's a tool perfectly designed to have reliable diagnostic and to guide you in the right direction, and then you will use the profiler and do your thing. So again, for those what exists for the future, you can go to demo.blackfire.io and give it a try for yourself. Yeah, so let's go there. So by default, when Blackfire monitoring is enabled, all the HTTP traffic is being collected. That's great. You can play with the sampling rate. And you also have the possibility of monitoring your CLI services. We don't have much in this simple application, but if you are using workers, or if you are using, you're triggering periodic CLI commands that may be greedy at time, like monitor them. My advice is like monitor all the things, profile all the things, and test all the things. You can go back to the web. You can display wall time, memory, request per minute, load, output. You have many stuff you can play with. It's awesome. You can narrow down by some specific HTTP status or response time to only display the slowest entries. You also have a breakdown of your response time per service. So maybe the bottleneck you're looking for is not within your app, but within the services you are using, and you will see the contribution to all the services you are using, SQL, HTTP requests. So you have all the breakdown there, could be super efficient. And you have there a list of the top transactions. So Blackfire will compute, will make this list, and you will be able to see what part of your application has an impact on end users. Can I zoom? No, I can't. We can see in our application that the first two endpoints are not the first two endpoints. Yeah, those one. I clicked wrong way. So we have two endpoints that are very impactful, and some others that are not very impactful. So you may find some lagging stuff somewhere, but if nobody is using it, maybe you don't want to prioritize their optimization because it will make little sense. And monitoring will provide you that insight. And when you have this graph that can display the evolution of impact over time. Always good to play with this to understand some weird thing that could be happened. That's something I know that some of our users are having, like weird memory leaks situation they barely can understand. And graphing this will point you in the right direction because you will see what part of your application, what endpoint, at some point, for a reason we don't know yet, end up with a surge of memory. So play with this, and you will find what you're looking for. And when you found something, you can click on it, have the monitoring dashboard for that request. That's awesome. And now you have a list of spans, meaning individual service calls that are contributing to this response time. So in our situation, yeah, we can see that we have some specific SQL queries that might be worth exploring. And again, you can click on that SQL query and see things for your own. And you have a list of recommendations. So those actionable insights. And as always, you will have an information of impact. So fix things that has an impact first, and leave the rest for later or for never. You may not care. And you have also a list of automatic profiles. So Blackfire will compute every day a list of the 10 most impactful transactions, identified requests, if you want, and will trigger a profile for each of those 10. So every time the Blackfire PHP extension will see that request coming, and it will trigger. It will collect a lot of information and make a full profile. It will help you keep track on the health of those critical parts of your applications. And what's good with this is that you can make comparison over time. So you can make comparison, and in this situation, again, you may not see colors, but everything is OK. We have green stuff there, so reduction in time. We have blue stuff there. And if we push a new version of our application, you will see the difference, like what has been changed. So what part of the application has been removed and has been updated in some plain sales. We are lucky this time because we have a degradation. But when I rehearse, it was a degradation. So good to know. But it's great to have this ability of keeping track of your application with only one click right from there. And you can also trigger some requests there. So monitoring, quick introduction, but it's a great way of making a diagnostic and to know what to prioritize and what not to prioritize. But in a firefighting situation, it's great, but again, it's maybe not enough, because you don't want to spend your day watching the monitoring. What you want today is carrying on with your life, build code, build the application, add value to your end user. You don't want to wait in front of the monitoring for something to crash. That's not what we want to do. And of course, what you could use is alerting. That's another tool at our disposal, so you can set up as many alerts as you want, and you will be the first one should anything happen to your application. So in this example, if the response time is above a certain value for 5 minutes, then we will have yet another Slack notification or an email, and you can decide wherever you want to be notified when something bad happens, but also when there is a cooldown. So this way, you will be the first one if anything bad happens to your application. So it's good, because you have a bit more time to react before your customer are starting to call, because this is not something we like. But again, maybe it's not enough. It's great. We should use alerting, but maybe we could use something more. There is one extra tool, which is called the health report. So the health report is a bill of health of your application based on the data of the last 7 days by default. You can pick any time you want. And you have the evolution of response time, request, errors. You have some top recommendation. Good. So we clearly know what to prioritize. We have the most impactful transaction for those 7 days, the one that are gradually degrading, which this is gold, that maybe you pushed something a few weeks ago, and things are starting to go sideways, or there is a shift in usage in your application, and you will be able to notice this. And same with services call. You will know what are the most impactful calls and what are the ones gradually degrading. So it's great. And my advice will be to spend 1 minute, no more, at the beginning of your day, checking this bill of health. And over the time, you will start to see, to have early sign of shifts in pattern, something that was always the same start to become different. So maybe you push something in your code, maybe your users are using your application in a different way. We don't know. You will be able to know, and you will be able to act before there is something bad that could be happening. So that's quite useful. So we go back there. So we have some new tools. We have the alerting, we have the health report, and it's not displayed. So far, our observability toolbox is composed of a reactive tool, the profiler, and some proactive ones that give us each time a bit more leeway to act. Monitoring, alerting, health report. But again, maybe it's not enough. I don't think it's enough for us to say, we will stop firefighting. What we want is to enforce performance and stability. We want to know the consequences of the changes we are making. We want to assess, to have early signs of what could be happening if we push that to production. And what we want is performance test. Well, I don't know what we want, but we need, so we have to do it. And I know that all of you are doing tests every time they make a pull request, so that's great. For that. I do too, of course. And we will add some performance tests. You have no proof. So, what I love with Blackfire test is they're YAML-based. So with very simple, lightweight YAML files, snippets, you will be starting to create a bulletproof vest for the performance of your application. In this example, for all category pages, is regular expression, obviously. We expect a wall time below 100 milliseconds. We expect to make 5 or less SQL queries, and we expect to create less than 50 entities. Let me just pause here for an advice. My advice for you will be to test the cause of your performance, not the consequences. Of course, you want to assess the time. You want the time to be fast, short, of course. But time is volatile. So what you should use as a reliable test is to assess the cause, why your application is fast. Your application is fast because you are not making too many SQL queries. You're not creating too many entities and computing chain set like hell. You are not going within that very greedy function. You are not doing some specific stuff. Test the cause, not the consequences, and you will have reliable tests. Of course, you can test all the things. Blackfire, do everything, all the things. In this example, we are testing CLI commands. And we, again, are assessing query counts and entity creation. And also, we are using, at the bottom of the screen, I don't know if you can see it, but we want to see if this user activity calculation has a new count. We want this not to be seen, because you can create metrics as well. Blackfire provides like 600 metrics. It's a lot. But maybe the most efficient one will be the one that you will create yourself based on your application logic. And this is, in this very simple example, that's the tip of the iceberg of what we can do for this. Every time we are calling this count recent comments for user of this helper class, we are counting that metric. And we are counting its contribution to all the available dimensions. In what could be done, that you could assess that the functions that are being used to warm up cache are never called in production. Like they should be called when you are warming up the cache, never in production. And I'm saying this because I know someone, I won't say his name, but that did this. And maybe you too, actually. Maybe it's not me. And every time you will make a profile, all the matching assertion will be evaluated. So again, you don't need to see colors. It's in green, but you have a check mark. You will know what went well and what went wrong. And it's good. But again, maybe it's not enough. It's never enough. Because this is great. And when you will work in some part of your application, you will use the profiler because it will give you some magnifying glass to know exactly how your application is behaving. You will save a lot of time. But what you don't want to do is every day go on all the endpoints of your application and trigger a profile to assess, to see if all the matching assertions are met. I'm not saying, again, we are lazy. I'm saying that we love automation, and this is what we give you. We give you automation, and this is also super great, and this is the last tool I'd like to introduce you today. And again, with Lightwave YAML files, you can describe as many scenarios as you want, containing as many steps as you want, and it will be processed by Blackfire Player, which is an open source web crawler that has an ability of triggering profile. It's as simple as that. So in those simple examples, we are saying, OK, we'll visit the home page, and we optionally can add some expectation on top of this. We expect a 200. It's a blog. We expect to have at least a list of 10 entries. You don't have to use this for that. You maybe have other tool at your disposal. Then we will visit the other page, and we will click a link. We will submit a form. We may send a payload to an API. You can do as many things as you want. You can even reuse part of the code. Assess for anonymous users. Do the exact same thing when logged in. And at the end, you will have a convenient report, what you call a build report, but it's a report. And you will have a visual information of all the results for all the steps of all the scenarios. And that's great. That's truly useful. And you could trigger those builds with a CLI. You can schedule them on a periodic basis, or every day, every once a day, once an hour, like what you want. My advice will be for you to secure at least the critical user journeys. It will be great if you could cover all your application with performance tests. But clearly, that won't be the case. It's too much. It may be the case if you are starting from scratch, then we can slowly build something. But if you are adding Blackfire because maybe Black Friday went not very well, that could have been the case, then at least start by the critical user journey, write tests to make sure that they at least stay where they are, and slowly you will optimize those endpoints and expand your test coverage. And that's a sustainable way of controlling the performance of your application. And you could automate even a bit more, like plug in with your CI/CD pipeline. So every time you make a pull request, those tests will be triggered without asking for them. And you could prevent merging a pull request that will degrade the performance of your application. Same with deployment. You can block the deployment of a version of your application that will introduce performance regression. That's pretty good. So now we are reaching the end. And maybe I will finish in time. That's great. Now it's up to you to build your strategy. So you could use all of the tools I introduced you today. You could use none of them. You can use some of them, mixing with others. Fine with me. Performance is a feature, and you are the one that should be designing that feature. So try to see what tools you could use and how you will smoothly integrate them in your development and deployment workflow. Of course, we came with an advice, but it's up to you. Like, use monitoring to know when and where something could happen, and make diagnostic and prioritization. Then use the profiler to understand why your application is behaving that way there. Fix the issue. Make profile comparison to assess side effects. Write tests. Automate. Repeat. And you will have a nice process. Of course, you could use Blackfire on all environments: local, dev, staging, pull requests, production. And if you are using a PaaS, such as Upsun, that will be presented by Guillaume in this room right after the break, Blackfire is already included and available on all PHP and Python environments. So you don't have to care about configuring stuff. All you have to care for is building your application, because you should spend way more time building your application than dealing with the consequences and finding for information. In short, Blackfire empowers you developers to monitor your application behavior and proactively identify bottlenecks and the consequences of upcoming changes. Today, Blackfire is providing deterministic observability for PHP and Python. That's great. And I'm super thrilled to finally be able to announce that early next year, maybe end of Q1, we will introduce continuous profiling for PHP, Node.js, Go, PHP, Python, Node.js, and Go. So maybe a big chunk of your dev stack will be covered by Blackfire, and that's super great. And I cannot wait for you to give it a try. The continuous profiling is already used for PHP and Python. Is already used. No, for Node.js and Go is already used in Upsun. So that's super great. And there is one last thing. So I will take my sales hat. I'm not a salesperson at all, but I will put my sales hat. Bears with me. There is a quite unique 30% lifetime discount you can have. So if you go on our blog, blog.blackfire.io, there is all the explanation for an offer for Black Friday. Sadly, this offer will end on Sunday, so you have quite short notice for us at SymfonyCon to redeem that coupon and make a decision and redeem that coupon. So I've got a game for you. If you scan this QR code, you will end up in a Blackfire escape game. It's based on Alice in Wonderland, so you've found in some kind of magical world. And we will try to escape that magical world with the tools we know as developers. So you have a code base, you have a tool that you will be able to use for free on a website that is designed for this. And if you reach the end of this escape game, you will find a coupon code that you could use. You could redeem at the end, until the end of the year. So you have barely 1 month, or not 1 month to redeem it. That's cool. 30% lifetime discount, like we are rarely doing this. So maybe you don't need this, but at least we'll spend 10 fun minutes. And if you finish that escape game during the conference, you could also win a Lego set. You can join a raffle to win a Lego set. That's great. So give it a try. Thank you so much. I don't know if we had a lot of time for questions. 2 minutes, but yeah. Thank you. And I will be at the end of the. I will be at the booth. I'm the Blackfire guy at the booth. You have a question? I'm very bad at. Oh, I made it.
I'm wondering, in terms of profiling something like live environment, staging, or production, what kind of overhead in performance Blackfire adds when you try to?
That's a great question. So, depending on the information you are collecting, the overhead will be different. With monitoring, monitoring for production, obviously, makes little sense in development. The overhead is minimal, depending on the complexity. The overhead for Symfony application usually 0.5%. So it's barely minimal, and usually you don't see the difference. There will be a much higher overhead for profile, but only you, the person triggering that profile, will be affected by this overhead. The other threads are not affected by this. It's only you. When you are requesting a profile, there is a specific header sent with your request, and we will collect this information. So you will be the only one experiencing this, and depending on the complexity, can go up to 20, maybe more, depend. But end user won't be affected by this.
So if I need to understand this better, I would be reading the profiling, profile documentation on the website to be able to configure it so that maybe certain IPs or maybe certain groups or stuff like that. Can I find that information there so we don't take too much of the time?
Well, yeah.
Okay. Thank you.
And the browser extension I show you is nice for triggering this, but my favorite way of triggering profile is with the CLI. So I will know some specific endpoint I want to use, so I can do Blackfire curl with a curl command and reproduce exactly this. So that may be a way you can do this without annoying other people and know exactly what you are looking for.
Okay, thank you.
I don't know if we have time or if we have other questions.
I'll throw it back first.
Can I catch it? First time I managed to do sports. Well, thank you so much, I guess. This is the end. Thank you.